Hello guys, welcome back to my YouTube channel. So today I'm going to solve day 26 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 1334. We have to find the city with the smallest number of neighbors at a threshold distance. Okay, so see this particular example. So here there are total n cities. Okay, there are n cities numbered from 0 to n minus 1. Okay, so this is city number 0, city 1, city 2 and city 3. Okay, then after that we have given the array edges. Okay, so see this array edges. So this 0 simply means from this city, and this 1 means to this city, and this 3 is nothing but the weight. Okay, so from 0 to 1 weight is 3. So from 0, if I go to 1, the weight is 3. Okay, so actually this is a bidirectional. So here 0 to 1 or 1 to 0 weight is just 3. Okay, and then 1 to 2 or 2 to 1 weight is just 1. Okay, so 1 to 2 or 2 to 1. Okay, any path. Okay, it's a bidirectional. Okay, not a directed graph, so weight is just 1. Okay, so I hope that this is clear. Then we have one distance threshold given to us. Okay, so what we need to do here, so we have to return the city with the smallest number of cities that are reachable through some path. Okay, so here if I want to move from city 0 to city 1, so what is the weight, total weight that I'm going to take? Okay, only 3. Okay, so this is just a little bit cost. Okay, just 3, and distance threshold is 4. Okay, so 4 is a distance threshold, and I am just taking this 3. Okay, so 3 is smaller than 4 now, so this is good. So I can visit city 1 from city 0. Can I visit city 2 from city 0? So here total distance 3, then here total distance is 1. Okay, so 4. So 4 is less than equal to this distance threshold. Okay, so I can visit city 2. Can I visit city number 3 from city 0? So 0 to 1 I go first. Okay, there is no direct path now, 0 to 3. So 0 to 1 I go first 3. Then after 3, if I go this path, 3 plus 4 7, then 7 is greater than my distance threshold. Okay, so I can't visit this city. From city 0, if I go to city 1 3, then from 1 I move to this 2, then 3 plus 1 4, then from 2 can I move to 3, then total distance 4 5. Okay, 3 plus 1 plus 1 5. So 5 is also greater than this distance threshold. Okay, so I can't visit city 3 from city 0. Okay, so same way we have to get the city 0, city 1 and city 2 and city 3. So from city 0 and city 3 we are visiting minimum number of cities. Okay, minimum number of cities. So we have to return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. And if there are multiple such cities, where we have to return the city with the greatest number. So city 0 and city 3 have minimum number of reachable cities, and out of city 0 and city 3, which city has a maximum number? So this city 3 now, this is 3 and this is 0, so 3 is greater than 0. Okay, so we have to return the city with the greatest number. So 3 is greater than 0, so that is why my output is 3 in this problem. Okay, so I hope that you guys are clear. Okay, so now let's understand few more things. So this is disastrous algorithm. So it is a graph search algorithm that finds the shortest path from a single source vertex. Okay, so this is important point, from a single source vertex to all other vertices in a weighted graph. Okay, so this is one main point for this disastrous algorithm, and this is Floyd Warshall's algorithm. So this Floyd Warshall algorithm is a dynamic programming algorithm that finds the shortest path between all pair of vertices in a weighted graph. Okay, so this is one important point. Okay, so now let's do the comparison here. So for this disastrous algorithm, this is a single source shortest path, and here I am checking for all pairs shortest paths. Okay, so this is more beneficial for me right now, all pair shortest path. Okay, so see the use cases here. So when you need the shortest path from one specific source to all other nodes in a graph with non-negative weights, such as in network routing algorithm, okay, then we use this disastrous algorithm. But in case of Floyd Warshall's algorithm, when you need the shortest path between all pair of nodes in a graph, such as evaluating all pairs of shortest path in a road network or for transitive closure of graphs. Okay, so this is more beneficial for me, Floyd Warshall's algorithm. Why so? So I will explain this example, okay, later on. But see first here. So time complexity is of v square. So here time complexity is of v cube. So you are going to say that here time complexity is less, but here lies time complexity is greater. So why not we use this disastrous, which is nothing but greedy type algorithm. Okay, and this Floyd Warshall is nothing but dynamic programming algorithm. So see here, from single source, let's say there are total 4 nodes A, B, C, D. Then from A single source I am moving, checking the shortest path na, B to C and A to B, A to C and A to D I am checking. But I need to do the same thing for all the cities na. For this particular problem, I have to do the same for all the cities, all the 4 cities one by one. So for B also I need to check for A, C and D. Okay, so this is the same thing that I need to do for all now. So this is just for a single source, it is V square. But if there are total V cities, let's say the number of cities are V, then it is going to be of V cube only. Okay, for this for our problem. Okay, because we have to find for all the cities now. So that's the reason. Okay, so here uh, anything else is important. Okay, so just go over this comparison, and these are the use cases. Okay, and these are the steps how we are going to implement this Floyd Warshall algorithm, and these are the steps how to implement this disastrous algorithm. Okay, so just go over these points. But in this problem I am going to solve the problem using this Floyd Warshall algorithm. So let's see this example. Okay, what is going to happen here. So first we have to initialize a 2D array distance, where distance of ij is the weight of the edge from vertex I to j. Okay, vertex I to j, the weight. Okay, and if there is no such edge exists, okay, if there is no edge, then I have to just set distance of I to j is infinity. Okay, if there is no edge. Okay, and distance of a particular edge from itself, okay, to itself, I. Okay, so then I am going to just set it to 0 for all the vertices. Okay, so from 0 to 0 I am going to take distance 0, from 1 to 1 I am going to take distance 0, from 3 to 3 I am going to take distance 0, from 2 to 3 I am going to take distance 0. Okay, that's the simple meaning of this one. Okay, then for each intermediate vertex k from 1 to v. Okay, so let's say I am moving from this vertices 1 to vertices 3. Okay, and then after that I need to see if I move this path. Okay, 1 to 2 and then 2 to 3. Okay, this is also one more path. Okay, so here this is intermediate. Okay, this is intermediate vertex. Okay, let's say, so we have to update then distance of I of j. Okay, so 1 to 3 I have to update the distance now. So I have to update this distance as minimum of distance. Okay, minimum of what? Minimum of this 1 by 3 or 1 to 2 plus 2 to 3. Okay, whatever the minimum is going to be my distance. Okay, so this is what we need to update. Okay, that's a simple meaning of this line. Okay, after considering each vertex as an intermediate point. Okay, so I am going to consider each vertex as an intermediate point. Then I have to update distance of I of j will contain the shortest path distance between all the vertices I and j. Okay, so now let's understand this with an example here. So this is nothing but Floyd Warshall algorithm. Okay, so initially let's see this is a graph given to us. Okay, so here this is a directed graph. Okay, in this case, so here you see I am going to create one matrix. Okay, so this is one 2D matrix. So total number of edges, total number of vertices are 4. So it is 4 into 4 matrix that I am creating. So here 1 to 1 I am setting distance as 0, from 2 to 2 I am setting distance 0, from 2 to 3 I am from 3 to 3 I am setting distance 0, from 4 to 4 I am setting distance 0. Okay, so this is initially. Okay, these are the things that we need to set. Okay, then you see 1 to 2 if I am moving, then what is the total weight? 1 to 2 I am moving, total weight is 3. Okay, so I hope that this is clear. Then 1 to 3. Okay, 1 to 3 if I am moving, so 1 to 3 there is no edge, right? There is no direct edge. 1 to 3. Okay, so here I'm just writing a direct edges. So 1 to 3 there is no direct edge, so I am just writing infinity here. And 1 to 4, now if I want to move 1 to 4, then direct edge 1 to 4 is 7. Okay, this one. So here I am writing 7. Then same way from 2 I need to check. From 2 if I want to move this one. Okay, so 2 to 1 is this edge 8. Okay, so this is what we need to do. Okay, so in this way I am going to fill all these values. Okay, initially, and this is matrix A of 0 simply means direct path. Okay, if there is any direct path or not. Okay, then I have to create A1. So what is the meaning of this A1? A1 means here intermediate path. Okay, intermediate path. Okay, so now let's see how I'm going to update here. So A to 1, that simply means I have to go through the edge, go through the vertex 1. Okay, so here I'm going to write the same things for this 0 3 infinity 7. Okay, so this is the same line 0 3 infinity 7, and from 0 8 5 to this column I'm going to write the same thing. Okay, and other things I need to fill. Okay, because now intermediate is 1 now, and these are the ones direct path. Okay, 1 2 3 1 to 2 1 to 1, this is direct path now. From 2 to 1, okay, this is direct path now, right? 2 to 1, okay, if I want to move 8, so 8 is there, so this is direct path now, so I don't need to update all these things. But now instead of this, see here I am writing 15. Why so? I am updating other things. Why I am writing 15 here? So how I'm going to write? So first see a of 0, and here see 2 to 4. If I'm moving 2 to 4, then what is the distance? Infinity. So see here 2 to 4 I need to move, but there is no direct edge, so this distance is infinity. And here intermediate I am taking 1. Okay, intermediate I am taking 1. So here I am, what I am doing, a of 0. If I choose this vertex 1 as intermediate, so now a of note, then 1 to 4. Okay, so now see this. So intermediate is 1 now. Okay, so intermediate, since intermediate is 1, so right, that's why I'm writing here 1. So 2 to 1 there is path. 2 to 1, yes, 8 is there. 2 to 1, and then 1 to 4 is there any path? 1 to 4 is there in path, so 7 is there. So 7 plus 8 is 15. So we have to write the minimum now, minimum of this. So this is the formula that I have used here now, minimum. Okay, intermediate vertex. Okay, so minimum is 15, so that is why I'm updating 15 here. Okay, so if you want to see it diagrammatically, graphically, so see 2 to 1 if I move, so 8, then here 1 to 4 7. Okay, so here I am updating 15. Okay, so in this way I have to write, I have to fill my A1 matrix. Okay, then for A2, okay, so for A2 I am going to keep these things fixed. Okay, 3 0 8 5, so these things are same. Okay, and this row will be same 8 0 2 15, and other things I need to update, and this is always 0 now, diagonally always 0. Okay, so diagonally always is going to 0. Okay, so for A3 I am going to keep these things as fixed 5207, see from here, and this 5801, and other things I have to fill. Okay, so this is the formula that we are using. So A of intermediate, okay, whatever intermediate, so here intermediate is 2, here intermediate of 3. Okay, so the for A2 I have to use this graph. Okay, previous one. For A3 I have to use this matrix A21. For A4 I have to use this matrix. Okay, so just go implement this formula. Okay, so this will help you. Okay, so how we are going to fill the values. Okay, so in the end this is the result that we are going to get. Okay, and this is directly going to show us the shortest distance from 1 to 1 0, from 1 to 2. So 1 to 2 it is giving 3. So see 1 to 2 if I want to move, so this is the shortest path. Okay, 1 to 3 if I want to go, it is saying that 5. So let's see 1 to 3 I want to move. Okay, so here first I go here. Okay, then I go here. Okay, so 3 plus 2 5. Okay, so that is why I'm writing 5 here. Okay, it is not giving any other path. Okay, so now if I want to go move from 1 to 4, so what is the path I'm going to use? So 1 to 4 it is 7 here. Okay, if I directly use this, but my result is saying 6. Why so? Let's see. So here 1 to 2 I move with 3, then 2 to 3 I move with 2, then 3 to 4 I move with 1. Okay, 6. So this is very good algorithm, right? Floyd Warshall algorithm. For all the paths it gives me the shortest distance. Okay, shortest weight from all the paths. Okay, for all the vertices. Okay, so this is what we need to do. Okay, so this is the main formula. Okay, so I hope that this is clear. Now see this example. Okay, so in this example also I am going to do all this same procedure, and in the end, okay, just like this end result, so I am going to get this end result. Okay, for this particular example. Okay, so after getting this result, we have to find the threshold is given as 4 now. So from 0 I can move to 1, yes. From 0 I can move to 2, yes. So total 2 cities, right? 1 and 2. So that is why I am writing 1 and 2. From city 1 I can move to city 0, I can move to city 2, I can move to city 3, because all have distance threshold less than equal to 4. Okay, so here I am writing 3 cities. For city 2 I can move to city 0, Okay, from 2 I can move to 0 because this is threshold to 4. From 2 I can move to 1. Okay, from 2 I can move to 3. Okay, so total 3 cities I am writing here. Then for city 3 I can't move this city 0. Okay, from 3 I can't move to city 0 because here shortest distance 5. Okay, and it is greater than distance threshold. Okay, but I can go to this city 1 and city 2. Okay, so here I am writing city 1 and city 2. Then these two have minimum number of cities, city 0 and 3, and this city 3 is the greater number, so I am returning 3 as output. Okay, so now let's move to the coding part. Okay, I am going to create a 2D array. So let's name this 2D array as distance. Okay, and here inside this I have to give the size as n and n. Okay, that is number of vertices that I have. Okay, so here if you just go to this steps, so we have to initialize a 2D array distance where distance of ij is the weight of the edge from vertex I to j, and if no such exists, then we have to set distance of I of j to infinity and set distance of I to 0 for all vertices. Okay, so here once this is done, then after that what I am going to do, initially I am going to fill all the values in my this 2D distance array to infinity. Okay, to the max value of integer initially, except for the values these one. Okay, distance of I to I. Okay, from each vertex to itself I am going to set to 0, and for all other values I am going to set that to infinity. Okay, so for that I am going to run one loop for int I is equal to 0, I is less than n, I plus plus, and after that here I am going to use this arrays dot fill function. Okay, and here I am just going to pick first row. Okay, so this is my list of I simply means my first row, and in this first row I am going to fill all the values with integer dot max underscore value. Okay, so I have filled all the values. Okay, now once this is done, then I have told you now that from one vertex to itself I have to set that to 0. So here after filling all to integer dot max value, I am going to update after that distance of I to I is equal to 0. Okay, that's it. Okay, so I hope that this piece of code is clear. Then after that in our problem we are moving from this 0 to this 1, and this is weight. Okay, so now what I'm going to do, I'm going to iterate over all the edges one by one. Okay, so for that I'm going to use for each loop for int just pick one edge. Okay, so at a time I'm going to pick just this particular edge, then this particular edge, then this particular edge, then this particular edge. Okay, so here I'm going to use for each loop. So here what are the values given to us? So we have one from given to us, right? So here I'm just going to write int from, and then we have int 2 given to us, then we have weight given to us. Okay, total 3 values are given to us in a particular edge, right? So here I'm just going to write that. So from is equal to simply means edge of 0 value. Okay, 0th index. So edge of 1 is nothing but 2 value, right? So that's it. Okay, so I hope that you guys are clear side by side. Okay, whatever we am writing, so this is nothing but my edge of 2. Okay, that's it. Now after that, this is the array that we have created now. So in this array we have to add the direct paths. Okay, so see here, so initially age of 0, so here I am adding direct path now. So here I am adding 1 to 1 0. Okay, so it is already done, it is already done. And now all the values are infinity, but I have to update these values to 3 and 7 accordingly. Okay, if there is one direct path between them. So for that purpose what I am going to do here now, I am going to update distance. Okay, this array and index from this index to this index. Okay, so this is what I am going to update with weight. Okay, so easy, right? Since this is a bi-directional graph, not a directed graph, so here I have to update to from as well. Okay, to from, okay, to this index from this, okay, to from. Okay, so this is also equal to weight. Okay, so this is done. Okay, this is done. Okay, then after that I have to apply Floyd Warshall algorithm. Okay, so how we are going to apply this Floyd Warshall algorithm? So let's do that. So I have to iterate over all the rows and columns one by one. So here I'm just going to write int I is equal to 0, I is less than n, I plus plus, for int j is equal to 0, j is less than n, j plus plus. Okay, okay, this is done. One second. This is done. Then okay, I have to iterate row and column wise na, but also I am generating this na k value. Okay, this is k value na, so k I am also generating here 0, then 1, then 2 intermediate, then take 3 vertex as intermediate, then take 4 vertex as intermediate. So what I am going to do, so here I am going to use one more loop, and I am going to run this for loop for int k is equal to 0, k is less than n, k plus plus. Okay, so this is what we need to do. Okay, and here just try to make like this. Okay, so now let me reformat if it's possible. Yes, so this is what we need to do. So okay, so here in this part what I'm doing, I'm applying Floyd Warshall algorithm. So since we are using these 3 loops now, so that is why you see the time complexity, it is mentioned I think somewhere in comparison. Yeah, so here see, that is why the time complexity is of VQ for this Floyd Warshall algorithm. Okay, so in this part I'm just applying Floyd Warshall algorithms. Okay, so let me write the comment, apply Floyd Warshall algorithm. Okay, so now inside this what I have to do, so I have to just implement this formula that I've explained. Okay, how we are getting the values. Okay, so I hope that you guys are already clear. Okay, how I'm filling the values. So this is a simple formula that I have to implement, but first let's check that these two values are not infinity. Okay, so if these two values are infinity, then definitely I don't have to find the minimum. Okay, but then directly it is already there now, then I don't need to update. So just check if these values are not infinity. So what I'm going to do here, I'm going to write if distance from I to k, that is my intermediate vertex, okay, this is not equal to integer dot max underscore value. Okay, this and just copy this same thing and paste it here, distance of I to k, now k to j. Okay, so this should be small. K j is not equal to integer dot max value. In that case, simply apply this formula. Okay, so here I am just going to write distance from I to j is equal to math.min of distance of I of j. Okay, this distance, comma distance of I of k plus distance of k to j. Okay, simple formula, right? So I know that this is very easy for you now because you have already paid attention to this part, right? So this is a simple formula that we are using. That's it. So that's nothing but our Floyd Warshall algorithm. That's it. Now we have to solve few things that is given in our problem statement, that is find the city with the smallest number of reachable cities within a threshold. Okay, so this is what we need to do. Okay, so now we are done with this graph. Okay, we are ready with this graph. Okay, using applied Floyd Warshall algorithm. Now after that we have to just check for all these things. Okay, so here I am going to write initially, let's take my min count as integer dot max value. Okay, int min count is equal to integer dot max underscore value, and then take the result city. Initially let's take this value as -1. Okay, then I have to check all these cities na, city 0, city 1, city 2, city 3. So here I'm going to run one loop for all the cities one by one. I have to check na. So int I is equal to 0, I is less than n, I plus plus. Okay, so inside this initially count is 0. Okay, so I have to count the number of cities that I can visit na. So initially I'm taking count as 0. Then how many cities I am visiting from this 0? So I'm visiting all these 4 cities na. So here inside this again I have to run one loop for int j is equal to 0, j is less than n, j plus plus. Okay, this is done. Then after that I don't have to consider these cities where my I value is equal to j. Okay, I don't have to consider these cities. So here inside this I'm just going to write if I is not equal to j. Okay, this thing, and here I have to just check distance of this distance na, this distance values 0, 3, 4. Okay, these values should be smaller than or equal to this distance threshold. Okay, so this is what we need to write. So here I'm just going to write distance of I j should be less than equal to distance threshold. Okay, so if this condition is satisfied, then just increment the count. That's it. Okay, for this particular city I'm just getting the count now. So for this city I'm going to get the count as 2, for this city I'm going to get the count as 3, for this city I'm going to get the count as 3, for this city I'm going to get the count as 2, right? So now once this is done, then after that here only I have to check if my this count, okay, if this count is less than my min count. So initially min count is a max value integer, so definitely this condition is going to satisfy. Okay, so here inside this I'm just going to update my min count to count. Okay, because I have to find the result for minimum count cities na. I have to find the result for these two only because these are the minimum number of cities na. So here if my count is less than min count becomes count, and my result city is going to become I value. Then you guys will say that both city 0 and 3 have same number of cities. So what we have to do here? So here I am going to write one more condition. Okay, or if my count is equal to min count and my I value is greater than the previous result city value, then I have to update this part again. Okay, because I need the result city with the maximum number, right? City 0, city 3, city 3 max number, so 3. So in the end I have to just return the result city. That's it. Okay, so code is very simple, right? So now let's run the code, and if there are any issues then we will try to fix them. So nice, so all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And you can see the time complexity for this one. The time complexity is going to be of n cube, right? And our space complexity for this part is of n square. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.